So now we have a trim pot. It can output any voltage within the supply voltage range. It's about 5 volts. Now I'm going to put it to about 2 volts, and we're scrolling this very slowly because we're going to look at a few different voltages. So that is being fed to the base of the PNP bipolar junction transistor emitter follower, where this jumper is, and I plug it in. You can see it's about 0.6 volts higher right there. So that's the way the emitter follower goes, but it will follow that voltage. And not the complete supply voltage range, but pretty close. Now we're going to the emitter of the NPN bipolar junction transistor, which is following the PNP voltage, but it's 0.6 volts lower. So it's about 0.6 lower. But the main thing is, now we're back to that initial voltage that we set. So if I set the trim pot to 3 volts, then the output will be 3 volts there. We'll get the same voltage between these 2 points, but we have to cascade NPN and PNP bipolar junction transistor to do this. And here's our schematic diagram for our cascading PNP emitter follower and NPN emitter follower. So first off, we set a signal with the trim pot. We can go all the way down to 0 volts or all the way up to 5 volts, but the main output may not go the full range. So in any case, let's say we got 2 volts there going to the PNP bipolar junction transistor emitter follower. Transistor is going to do what it takes to conduct in order to set 2.6 volts there, about 0.6 volts higher than the signal, because we got a pull-up resistor, and that sends the signal to the NPN bipolar junction transistor emitter follower right there. So we got 2.6 volts there because it went up a little bit. This brings it back down about 0.6 volts. So now we're back to 2 volts, what we set with the trim pot as the output, and we got the pull down resistor to help do that. But ultimately the power comes from the NPN bipolar junction transistor, so we can provide a lot more power than the trim pot would have been able to do.